Welcome to the Industrial Talk Podcast with Scott MacKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, welcome to Industrial Talk. Thank you very much for your continued support of this platform that celebrates industry professionals all around the world. You're bold, brave, you dare greatly, you innovate, you collaborate. You are solving problems each and every day. That's why we celebrate you on Industrial Talk. We are broadcasting, as you can tell, from the buzz in the background, DistribuTech. Dallas, Texas is the location. We've got our worldwide headquarters studio set up here, and it's rocking. Great conversations. Can't complain. I am not going to complain because we have somebody in the hot seat. Ben Lanz. Osmose is the company. We're going to just pepper him with questions. We're not.
I thought you said it was going to be easy.
It is. No, we're gonna have a good conversation. How you doing, Ben?
I'm doing great. It's great to be here with you at DistribuTech, Scott.
Yeah, and we're at the very end. I mean, I think the next stop outside the doors is what? Concrete and freeways. It doesn't get any further away from the action.
Well, there's a lot of action in the utility business.
Can you believe it?
To Texas. A lot of people moving to Texas, and Texas will...
ERCOT.
Scott Carpenter just got on the stage this morning and said they have just gigawatts and gigawatts that they're looking at for AI databases or data centers and the people moving to this state. So they have a huge challenge, and
How are they? What did he say? I mean, how are they satisfying the gigawatts? I mean, the demand. I mean, come on. Help me.
I think he was more out laying out the challenges rather than all the solutions. And I think they're going to need to figure it out. Fortunately, it's not all going to happen next year. So I think that's what they're hoping for. But it's a massive challenge. And then that's all on top of this aging infrastructure that we have. And
they've been talking about aging infrastructure for, whenever I was a transmission line, it was aging back there. I was climbing towers built, I think, 1916.
Wow.
Yeah. Built strong,
right?
Quite beefy with bronze conductor.
No kidding.
Yeah.
Wow.
Yeah, you had to rig up the loops. They were dead ends, right? And you'd have to rig up the loops between the dead end insulators because you couldn't carry them with bronze.
That's something. I didn't know that. I learned something today. Thanks, Scott.
You're welcome.
But that brings me to really the point around Osmose in my background, which is the aging infrastructure has been something I've been involved in, diagnostics and so forth.
Tell us a little bit about that. What do you mean? Because Osmose is a leader, been around forever.
That's right, 90 years.
Yeah. How many?
90.
Yeah, it's been around. I just remember.
The wood pole guys, right?
The butt testing. That is, and then the plug. And then you'd look at the date.
Right. Absolutely. Yeah, they have a great brand and a great partnership with utilities, focusing on those wood poles for so many years.
Yeah.
And coming up with not only the diagnostics, the inspection techniques, but also how to upgrade them so that they last longer, right? Once some have some deterioration, but then they change that from just wood poles over to steel structures and concrete structures.
Yeah, that was
substation.
A must.
And it was just the utilities as a partner saying, hey, can you help us over here? What about over here? And now we've assessed millions of structures, but if you look at underground, Osmose has expanded to underground in the last well over a decade now, and they've done hundreds of thousands of assessments on vaults and transformers and cables and low voltage wiring, medium and high voltage. So they've really expanded their portfolio, and that's really where I came in. Over a year ago, I would have been with a different company called IMCorp, and we were acquired by Osmose because they saw they needed more expertise in the cable area. So that's really where my background comes in.
So what are you doing with Osmose outside of underground cable? What do you take us through a sort of a scenario there?
Well, they're tapping into our team experience, so not just myself, but the ImCorp experience, that small company that had a specific type of diagnostic that they needed. So my background is in dielectrics. I come out of the University of Connecticut, and I had a professor there who was a director of installation research, so I come out of that background. And so there's myself and others who have expertise or experience in that area of materials, how they deteriorate under electric stress. And Osmose is tapping into really experts in all different areas, whether it be corrosion or obviously their 90-year tradition of being experts in the wood area, but also tapping into experts, like I said, with dielectrics, with materials to help utilities. We have a lot of young people coming in who perhaps don't know and don't have a deep knowledge in the deterioration mechanisms or the ability to upgrade those assets in an effective way to make them last longer, especially under extreme weather conditions that aging infrastructure and with weather it's not a great mix, right?
Are you doing lattice type towers as well?
Yes, absolutely. We do have huge business in addressing steel tower issues as they corrode and
they're everywhere.
They're everywhere, and if you want to just go and replace those or hang heavier conductors on them, you just can't go and do that because the structure isn't going to survive. So they've had a significant business over the last, well over a decade in just the steel towers. So, like I said, they've really branched out quite a bit.
Yeah, that whole conversation around steel towers and the aging infrastructure, and even back then, 30 years ago or whatever, we were talking about trying to reconductor, bringing in more capacity, more flow, and the structures just you couldn't bundle them together without a significant engineering transformation. You just couldn't do it, and so they kicked the can down the street. They never do. Let me ask you a question about underground cable.
Sure.
What is a typical, now this is transmission, I'm not going into distribution underground.
It's
transmission.
The same principles apply.
Sort of a life, how do you test a splice on an underground cable? Because how do you do that, assess the health?
Yeah, so there has been a lot of theories of how to do it, how to test it, and one of the challenges in our industry is people didn't really understand how those components deteriorated. So, in essence, the tests that people have used in the past really haven't been very effective because those tests can't detect the deterioration mechanism. So, some people have known this for a long time. The cable and accessory manufacturers have known how to test these products. In fact, they've had 100% quality control testing in the factory. And not only that, they've had testing during the design phase of these products, but that has not translated to the field because we didn't have the technology to do it. So the manufacturers perform what they call a partial discharge test. Partial discharge, it's the corona, it's the ionization of air that deteriorates plastic and rubber materials. Solid dielectric, I call it. So these solid dielectric components deteriorate intermittently over their lifetime, and it takes time to erode that material.
Can't see it.
You can't see it. You can't, sometimes in a substation, you can hear it. And if the lights are low, sometimes you see that blue ionization, the blue haze around products. But inside the cable, you can't see it, you can't smell it, hear it. You need technology to detect it. And the manufacturers did this in electromagnetically shielded rooms, right? Steel-walled rooms. They'd bring the product in there, they'd raise the voltage on it and detect electromagnetically, sensors detect this little micro-arcing. And if it existed within a certain range of the operating voltage, it said, okay, this product does not meet standard. They've been doing that since the 60s. But it's only really the late 90s that we figured out how to do that in the field because the background noise, the AM, FM, communication systems, the signals we're looking for are in the hundreds of microvolts. They're tiny signals, and you can't detect it unless you digitally filter the background noise down to the same level as the factory could see it. So what we did at the University of Connecticut is we figured out how to digitally filter that background noise out and achieve the same level of visibility as they could in the factory. So now we have a repeat process, a process that can repeat the cable and accessory manufacturers' quality control test in the field. And you can get, and because it's a time you're looking for a reflected waveform, a little tiny pulse that's reflecting in the system, you can tell where it came from by that reflection diagram. And if you could have 30 different defects in one cable and tell where they all are, location, and at what voltage they appeared. And as if those products don't have this micro-arcing to some significant voltage over the operating voltage, then we know that the product is good. If it has discharge very close to the operating voltage, that's very poor. That's going to mean it's going to deteriorate quite frequently because transients are very common at the lower voltage level. So how do we do it? We energize the system for just a few seconds. We monitor this micro-arcing activity inside the cable. We locate it, and then we can give, based on the industry standards, the manufacturer's quality control standards, we can give clear indication whether something either meets or does not meet specifications.
Yeah, that's interesting. Because I was getting ready to say, you jump in a vault and it's energized? I don't think so.
No. In fact, the technology is best applied to point-to-point cable systems. As soon as you have a network system, it becomes much more complicated.
Yeah.
But the principles still apply, and there's lots of different sensors that are available in the marketplace that if the activity is a large enough signal, you can, so to speak, sniff it out. Unfortunately, they're often less than a 2% solution at finding the problem or detecting the problem. So there's still that risk of people getting into a vault that when it's live, there really is not good solutions, and I don't advocate. I advocate for dead vault if someone's going to walk in.
No, I agree with you 100%. In your ability to be able to test cables, if you're saying point-to-point, can you detect a fault or a problem within that, like where it's at? So if it's an underground type of point-to-point, 30 yards down the road, that's where the fault is.
Yeah, or I would call it a defect, because a fault would be where it's already shorted out. And it's
Sorry, no
worry.
fault. I back up.
It's just definitions.
He's right.
Definitions, right? So, yes, you can locate typically plus or minus 3 feet or 0.1%, whatever of the cable length is the accuracy. So it's very precise in being able to locate what's going on. So you can tell if it's coming from a joint or splice versus the termination versus somewhere just in between in the cable.
What do you? I mean, I have to ask the question.
Sure.
Don't slap me.
Okay.
You're far enough away. You don't have to slap me. How is AI impacting this whole effort?
Well, as Mark Carpenter said on the stage this morning, they were working on AI before it was cool. Well, we were working on AI before it was cool too.
Yeah.
About 8 years ago, one of my colleagues said, "Okay, we're working on this machine learning. Let's, we got MATLAB, which is a large company involved in this AI space early on, to help us out. And the one thing we had was a huge database of clean data. To try to train a model, if you have junk data, you get junk in, you get junk out. So there's lots of excitement about what AI can do, but the one advantage we had is we had hundreds of thousands of line scans of entire cable systems with the truth, so to speak, right? We already knew where the problems were.
Yeah.
And we said, okay, here's what the end result is supposed to be. Now go and see if you can learn it. And we were able to compare, and we were able to develop AI because there's a human analysis part of this that was intense and hard to maintain quality. So AI, in terms of diagnostics, has made it much more easy to have high throughput. We used to have like 10 analysts looking at data all the time, hundreds of data sets coming through our little company every day. Guys in the field doing the assessments, they'd do a precursor assessment in the field, then they'd send it up and another human would look at it. This whole quality control process. Now we can send the data up to the servers, and it will take a first pass, and most of the time it's right, because the AI has learned what these waveforms mean, how to locate it, and how to present that data to a human. We still have the airline pilot scenario, so that there's a human there that says, yes, I agree with the autopilot.
Well, I agree with that. You should always have that human intervention,
right?
Just in case, just to give it the old, thumbs up.
Well, I mean, I think we're going to grow into depending on these technologies more and more. But it's going to take some time, and rightfully so.
But you're applying it to the tower inspections, the pole inspections. You're applying it to all of them.
That's right. We just had an announcement, which I think some of my colleagues are going to be talking with you about. Brian and Nira and Osmose are going to be Brian Reed, and Nira just announced that they're going to have a collaboration. So I won't steal their thunder. They know all about that. That's not my area of expertise.
So if you were to put your future hat on, what does that look like? What do you see outside of, you've already done the AI thing? Where do you see it going? Well,
I see it continuing to evolve so that right now the processors that we have are really only accessible on a server. We want to get that to the field. You see NVIDIA are building chips with lower power requirements that can do more and more. So we want to get that out to the field so that you turn the equipment on, it scans the line and tells you the result right there and tells you how confident you are. So there's not a back office approach that's where the AI core is now. So it'll be moving to the field.
I like it. Yeah, that's good stuff.
Well, we're going to have humans out there, and we're just going to give them better tools.
And we have to be more efficient.
That's right.
You're taking a business, you're taking an industry that tends to be inefficient, and trying to bring them along and make them more efficient. It has to happen.
That's
no
right.
doubt about it. It's going to have to. And because of the aging infrastructure, you better have greater insights into those assets.
That's right.
There you go. How do people get a hold of you?
Osmose.com, blanz@osmose.com.
Are you out on LinkedIn?
I am on LinkedIn. Easy to find.
You're cool. Now, that was a cool conversation. That was great. All right. Ben is his name. You need to connect with Ben. All his contact information will be out on Industrial Talk, so fear not. All right. We're broadcasting DistribuTech here in Dallas, Texas. It is a great collection of individuals like Ben solving problems. That's what they're doing. All right. We're going to wrap it up on the other side. Stay tuned. We will be right back.
You're listening to the Industrial Talk Podcast Network.
How about that for a conversation? Ben Lanz. Osmose is the company. You need to put this in your little scratch book and say, hey, note to self, reach out to Ben. And again, Ben's contact information is all out on Industrial Talk. Yeah, he's that good. We're talking about utility, grid, resilience, reliability. It is a really hopping market. Look into getting involved. Start with connecting with Ben. All right. We're building a platform. I say it all the time. Your voice needs to be heard. You need to be able to tell your story. You need to leverage the available social platforms out there so that we are better for it. Contact me. Yes, contact me. Go out to Industrial Talk. Click. Contact me. And then you'll be talking to me. All right, be bold. Be brave. Dare greatly. Hang out with Ben. Change the world. We're going to have another great conversation shortly, so stay tuned.